Okay, so in this session, we are going to talk about resource quota, and then we're going to talk about um, resource limits, like the container limits, hard limits, and the soft limit. So, resource quota is a setting up of a limit on the namespace itself, like I started to talk about in the last session. So it can be allocated at the namespace level, and it has to be done by the admin. So the whole purpose is that one team or project or environment, it does not consume all the resources. So there is in Kubernetes there's an object called resource quota, and if you see this, it has a lot of information about that, and it explains the purpose of using resource quota, and comes in very handy when there are when you want to enforce limits based on the namespace. So we will give it a try and see how it can be done, right? So I had, let me see, okay, I have how many namespaces? I have a dev namespace. So let's use that I just created in the last. There are no limits on it as of now. So I'm going to create the resource limits on CPU. I can limit the number of CPU, I can limit the memory, and I can do all that using the object. So I am going to just grab a YAML from my over here, hands on. And if you see, there is a yeah, this one. So if you see this YAML, it talks about creating a resource quota object itself. And this one is on limiting the resources on the default namespace, but I'm going to change it to dev. And this talks about a hard limit, which is only 2 CPUs, which is like very less for a namespace, but this is just an example. And 2 GB of limit on the memory, and then request. And so what's the difference between request and limit? Limit is a hard limit. So limit, so for example, if a pod is getting deployed, and the limit can also be specified at the pod level, I'll just show you in a bit. So if the limit is 2 GB, that means, and the request is 1, so the scheduler in the manager, what it does, it looks for the available resources on the worker nodes, that what the request is 1 and the max is 2, so it will try to find a node that has 2 CPUs and 2 GB available, and it will deploy the pod over there. And but in case the pod tries to use more than 2 GB, which is the hard limit, and 2 CPUs, then in the Kubernetes orchestrator, what it does, it will kill the pod, and it will be called like out of memory exception. And in the case of CPUs, it doesn't kill the pod, but it does, what it does, it throttles, so the performance can be impacted of your application. So I will just grab this and I will deploy it. I'll do capital apply. Now this one was applied to default. I made a mistake. Okay, let me edit it. Let me see if I can edit. So you can edit. Where was it? To dev. Let's see if it takes it. We'll just delete this. Okay, and I'm going to edit it to see if to dev. I save it and I go back and I apply it and I do So there is one you see, and it explains what it is. Now I'm going to delete it, and I'm going to show you the limit and request. So limit is something that can be enforced on pod itself. So when it has to come from the pod spec, or I can leave it. So let me go back to that one. Resource. Let me just go back to the resource, one of the resource pods like this. And if I pick this one, if you see, go down there, it is when the pod is getting created, the container. So it's not defined in the pod. It's basically the pod email, but the specs is in the container. So the container is the one that's getting created. So the container should not be created. So it should only be scheduled on a node where the max memory limit is 228 megabytes and the CPU uses half CPU. So if I do so this is getting created. Dev. So we're trying to create a pod within the namespace which is requesting more memory than what it was. It's one request is 1 GB. So when I assign allocate this pod, if when I deploy this pod after this, the availability of this namespace will be less, because let me just see one more time. Yeah, we're creating in the namespace of dev, right? And the dev has already its request and limits. So let's see what happens. Okay, it's created. Let's see if it actually got created. It's running. And what is the... So if you see here, it already took the 64 megabytes out of 1 GB. And if I created another part, then the part won't be scheduled. So let's say if I create another part, let me ask 1 GB on that part, and not, um, right? It's the same thing, but I want to change the limit. I want to also change the request. Let me do that to 1. Yep. I have to change it, of course. The part name will be 2. I can keep the same label. The container name will be also different, which does not matter, but the image import. Okay. So this is called Nginx part 2. So limit part. Okay. Namespace. So I have to do this. Okay, now we are good. Now if I apply it, it will not be able to get allocated, because yeah, it won't even start because it cannot find a particular, it's going to exceed the quota. So that's the error. So the pod won't even be able to schedule. And if I change the namespace, of course, we saw that it works. So this shows that how you can enforce the limits on the namespace level, and then you can control the deployments. So that's it for this lesson. And then the next lesson, we will go ahead and start working on Multi-container pods. That's another very interesting topic. See you around. Thank you.